So what I want to do is I want to know what values for time and alpha are going to get me there. Okay, does that make sense? So what I want is this now. This is question one, well and truly. Okay, I want simultaneously, so for some single value of t, okay, I want x to be 2000 and I want y to be 0. Okay, and now you can see why I developed these time equations, right? Because there they are. There's my x value, right? And there's my y value. Okay, so suggestions. Come on, some of you can already see what to do. Where might I go first? What shall I start with? Because I am going to solve simultaneously. Where should I go? Where should I go? Well, you have these two choices, right? Which do you think is a better option to start with? Probably the x equation. Far simpler, right? So if I write this, x equals 200t cos alpha. But I have an x that I'm actually after, a specific x, namely 2000. Yep. Okay, now, look at this for a second. What does this mean? What is this all about? Constant. Constant? That's variable. I'm trying to find what that is. What about cos alpha? Also constant. So the only thing it makes sense to rearrange this thing into is to say, make t the subject. Right? Does that make sense? So t is equal to, cancel, 10 on cos alpha, by the looks of it. Okay? What is this time? This is when I've traveled from 0 and I've gotten to 2000. So far, so good? But at that time, that specific time, I also want y to be 0. Okay? So I'll say, also, right? There's my y equation, right? I want that to be equal to 0. There you go. So now I'm actually climbing with this particular point. And I can sub in my values of t. You get this. There we go. Okay, it looks a bit messy, but that's okay. Stay with it. What can I do with it? Well, let's see. That's 100, isn't it? So minus 5 times 100. That's minus 500. That cos squared alpha is on the denominator, so I can call him sec squared. And I think you can see why that might be a good idea to go, right? Good direction to go in. What's going to happen here? That's 2010. Aha. Okay. This is good. This is good because now we have an equation, alpha, which is the guy I'm trying to find. Okay. What shall I do to this before I actually whip out quadratic and all that kind of thing? I should change, well, there's two things I can do to make it simpler. I can change this guy with an identity, and I can get rid of all of this fluff, right? This is a bit of a mess, okay? So I'll do the numbers first. This. Yep, is that okay? Now we change this, sec squared is equal to tan squared plus 1, or 1 plus tan squared. Okay, so that's going to, if I rearrange this into a nice quadratic order, it's going to look like that. Okay, gross. Okay, that's all right. We can deal with it. Okay, can you factorize it? Not nicely. Okay, so I'm going to solve for tan alpha. Okay, follow with me, see if I get this right. Minus b, 4, plus or minus the square root of 16 minus 4ac, which is just 4. Yep. All on 2. So far, so good? Get going. 4 plus or minus the square root of 12 on 2. Now, this looks really awful. It looks truly awful. Before we calculate it, let's just note something. How many solutions are there here? There are 2. Why are there 2? Let's get our calculators and see exactly what it means. Now, you wouldn't expect to get something nice out of this, would you? Well, let's do one and then we'll do the other. Let's do the smaller one. 4 minus root 12 on 2. Tan inverse of 4 minus root 12 on 2. And what do you get? I'm looking for my first angle. Tan inverse of 4 minus root 12 on 2. If I've got it already, surely you guys can catch up with me. Let's do it in degrees, just for the heck of it. Someone got an angle for me? 15 degrees. Exactly 15 degrees. That's interesting. What's the other angle? All you need to do is change the minus to a plus, you get 75. Okay, that's interesting. What does this look like? My beautiful diagram, okay? That looks like it's about 75, give or take. Where's 15 on this diagram? Something like that, isn't it? Is that right? So in other words, there's a low angle and there's a high angle, and they both work. You can put them all in and they'll both pass through 2000, 0. Sure enough. That's interesting. You should note that. Very frequently you will get this double solution business happening. Okay? Now that's not the only thing. 15 and 75. 15 and 75? I'm suspicious. They're complementary. They're complementary. Why is that? If I drew a better diagram like this, and maybe you should do the same. I've got two solutions. Wow, that was lucky. Okay, now, where's my 15 degrees? It's here, right? My other angle, because it's the complement, is 15 degrees this way. That's suspicious, right? I wonder how you could determine whether that was a coincidence or not. I digress. There's my answer. There's question 1. Where do I aim? And the answer is here or here. Fine. Okay. Now, I've been talking to you a long time. I want you to see if you can finish these 2 questions and then we'll come back together. Because we've got 2 places to aim, you're going to get 2 answers for each of these parts. How long is it flying for? You ought to be able to anticipate an answer from these. And what's the impact, speed, and angle for each? Call them case 1 and case 2, and we'll come back together in 6 or 7 minutes. By parts?
I'm sorry.
I'm not even integrating, guys. Come on. Classic 4-unit student. It's like, I don't know. Must be by parts.
Oh my god.
Sorry, you just...
So if I had a heart attack right now, I'd be dead right now. So that really